Right, I would like to do a problem that's the reverse of one I posted before. In a previous problem, I gave you an intensity and wanted you to turn that to decibels. Now I'm going to give you decibels and go in reverse. It's slightly different math to turn it back to intensity, or at least it involves a step that we haven't done yet. So many lists I see of intensities say that 120 decibels is about the level of a rock concert. Now, it of course varies. It varies on what the band is, what the room is, and so on. I've read stories of Deep Purple playing one that read 117 on a meter, and people fell unconscious during the show. I've also seen records posted, one from The Who and one from Kiss. So one of those bands I like and one I don't. Um, Over 130 decibels, which is very, very intense. I don't think they measure or accept records for this anymore because safety and preventing hearing damage is an important thing. But yeah, 120 is quite loud and we can work with it. So what intensity is that in watts per meter squared? So I got the decibel formula out, but I have a different goal this time. So I have a number of decibels in there. And the thing that I want is this. I want to know what intensity produces a decibel level that's this large. So the first step is fairly easy. In order to get intensity by itself, like to divide both sides by 10 to get rid of the 10 that's there. So you have 12 equals the log of I over I0. So this is somewhat a tricky thing because normally when there's a variable you want, if this log weren't there, I could just multiply both sides by I0 and be done with it. But you can't get away with that here. I like to think of it like I over I0 is a quantity that's imprisoned in this log function. So we have to get it out. Now, just so you all see, this is my phone scientific calculator. There are all sorts of functions that have inverses above them. Now, so like if you have a Casio or a TI or something like that, does even better. But we see the sine and inverse sine, cosine, inverse cosine, tangent, inverse tangent. The natural log has an inverse function as well. And right, this is something I kind of don't like on this model. Normally, like x squared and the square root will be above each other, and then x cubed and the cubed root will be above each other. These powers and roots are properly set up so that the same button shifted gives you the inverse function. So one thing to notice though, this one is done correctly. You have log, and the inverse function is 10 to the x. So these are two functions that undo each other. So the log of 1 million equals 6, and 10 raised to the 6 is 1 million, for example. So that's the operation that has to go on. What you do is you take the logarithm base, you make that the base, and then the left side is the exponent. And here, take the logarithm base, and you make log of I over I0 the exponent. And this looks really complicated, but knowing that these are inverse functions, they cancel each other out. So you have 10 to the 12 equals I over I0. And so so if I multiply both sides by I0, like this, okay, 10 to the 12th times I0. That's 10 to the 12th times 10 to the negative 12 watts per meter squared. That's the threshold of human hearing there. Trying to make this, I should make this so this doesn't bounce so much. There we go. It's a little more stable. Okay. So 10 to the 12 times 10 to the minus 12 is 10 to the 0. That's the same as 1. So we have 1 watt per square meter. That's your intensity, right? So I mean, it doesn't seem like a large number, but that's an intensity in SI units that corresponds to a very, very, very loud thing.